Good morning, ladies and gentlemen, and welcome to this clip where we look at connection cost estimation in IDEA StatiCa. My name is Jacobus Oberholster. I'm an AEC and Procon technical consultant with Micrographics, and you'll see my email address in the bottom left there. You are more than welcome to reach out if you have any questions, even if it pertains to any of our other content or maybe something that you'd like to see us actually generate some content on. You are really more than welcome to reach out and let me know. Yeah, share some of your ideas. They always help. I'm not always 100% sure exactly what guys in the industry maybe feel like is lacking in the online space, and I'd be more than happy to look at any of your suggestions. So, all right, let's jump into our clip and look at connection cost estimation in IDEA StatiCa. All right, so there's two ways to set up your connection cost estimation. And one of them is when you've just launched IDEA StatiCa itself, so basically its main page, then you can go to project settings and change them there so that the changes reflect for every single connection. Otherwise, what you can do is in specific connection files, you can actually set up the costing values so that it generates a unique cost estimate for that connection. That can just be based on location. So you have a project that's quite close to manufacturers that pushes the cost down, or you can have a project that is in the middle of nowhere, which means that you're probably looking at additional transportation costs and maybe just problems with sourcing, which will push the cost up. So you have two options there. What I would recommend is you set up your base values, so just average values in your project settings, and then evaluate them for each connection thereafter. So how do you do that? So we click on project settings, and then what we're looking at is the little cost drop down over there. We can click on user preferences, and we can change the currency symbol from euros to R for rands. Then we proceed to cost defaults. Unfortunately, this does not update, so it still says euro per kilogram, regardless of whether or not we have this currency symbol. What we can do is just say save as default, go back and check if there is an update, and thank goodness there's an update. So what you need to do is just save as default first and then come back so that it reflects accordingly. Otherwise, it can be a bit confusing. So I have some generic values that I'm going to use. You're of course welcome to use these values. They're just based on random searches and just looking at some averages. They might be very different depending on where you are located. So for steel grade, I'm looking at a value of 150 Rand per kilogram. Of course, it says they're all specified. If you click on the plus button, you actually get a list of steel grades and you can modify the cost for each one of these grades individually. And that just generates a list of these materials. At the moment, there's 150 Rand per kilogram will be specified for every single one of those grades. For some reason, every now and again, an error pops up when I'm busy in here. I'm not 100% sure why. Of course, what can happen is we can just, after setting these things up, we are going to go and generate a connection and just look at whether or not it reflects correctly. All right, now we're looking at fillet welds. So there's throat thickness, again, all unspecified. So this is generic. And for that, I have a value of 160 Rand per kilogram. So this would be 160 rands per kilogram of welding material. This would incorporate the cost of your electrodes, maybe machine rental, the cost of the welder, etc. Here we have our CJP welds. So again, we have a welded plate thickness. We can set this if we click on there, but I might actually get an error here for some reason. Yeah, for some reason that makes my program crash. It is something that I will most definitely report and just hope that they fix. So just bear with me. I'm just letting it open up again. All right, so at the moment, don't mess around too much with your plate thickness. What we are going to look at is just adding a value here. So for all types of plate thickness, of course, we know that this will change as the plate thickness gets thicker, but these are just average values. So I'm going to put in a value of 350 over there. And then lastly, we have our bolt assemblies and then bolt grade. You can have bolt diameter. So if you click here, well, not bolt diameter, this is bolt grade. So there's a material 4.6, 4.8, 8, etc. Usually we'll work with 8.8, but again, you can specify for 8.8 and then 10.9, as these are the most common bolt grades that we make use of. Then you have bolt diameter, and you can set that up as well. You can see here we've started M12 and go all the way to M64. I don't even know if we get M64s in South Africa. I would imagine that would be a special import. So again, here I'm just going to give a rough value of 200 rands per kilogram. So I'm going to save this as default. And then what we're going to do is we can open up a connection file. And we are going to start building up our connection. So I'm going to go for a typical haunch. And what's lovely about that is the combination of just the cost estimation with also your analytical outputs helps you to really optimize your connection. So I'm going to look at something, let's say something like this for now, or let's look at something with some end plates. Okay, I'm quite happy with that. I'm going to just call this a normal haunch and typical moment connection at column beam intersections. Okay, happy with the Eurocode, happy with the steel grade, bolt assembly, and so forth. So I'm going to click on create, select a design, and we'll see that there's a 0 at the moment, and then that update to 629 Rand for the connection. So remember that that does not take into consideration the actual main members, of course. That's why that value is relatively low. To be honest with you, that does seem low even for this, so the welding of the plates and so forth. But let's look at just modifying some of these operations. So we've got our end plate, we've got a series of bolts. Of course, if we update the size, nothing will happen. All right, so just to be mindful, because we set it for all bolt sizes, let's maybe look at thickening or just increasing the size. So you can see that it updates, and that was small enough that it didn't actually change anything. If we look at our thickness, we can go to 10 mil, and that has a nice up, well, a 2 Rand, makes a 2 Rand difference, and we'll set these to 10 mil as well. Then if we increase the size of our welding, that will have an immediate effect. And on this side as well, we're going to increase the size of our welds. All right. Our load effects are in, everything is balanced. So what we'll do now is we're going to run our calculation and see where we land. Okay, so this is actually quite decent, just considering that we are at 0.1% plastic strain, which means that we do exceed yield at some point. But we can see here that if we go to check and we turn on equivalent stress, that there is really very little happening in these stiffener plates. So what I might do is remove both of these stiffeners and just put a capping plate on and see if that's fine. And then I might actually remove 2 rows of bolts over there. So we're currently sitting at 632 rands. I am going to delete these stiffening plates. And then I'm just going to put a capping plate on top. So we look for our stiffener. It is on member C. That's all good. And that's all good. And we just say end, just like that. And our weld is just on the front side. And we're going to set it to a value of 5 mils. Okay, thickness is going to be 10 mil. Okay, there's that. And then what I'm going to do is I'm going to look at removing these bottom bolts as well. So let's see about that. All right. So these 2 bottom bolts removed. Let's run our calculation. Let's hope that we haven't messed up this connection. And we see that it all is still very much great, actually. So we don't even need this stiffening plate. So again, we're going to go back. Let's remove the stiffening plate, or maybe we keep it there. We need to see. I'm going to delete that plate, and then I'm going to delete those 2 rows of bolts over there. Run my calculation again, and let's see. Okay, so we're at 0.3% plastic strain, which it really isn't bad. Our bolts are at 82.6 and our welds are at 97.2. Our cost has come down with just those minor changes. Our cost has come down from 632 rands to 207 rands. Now, again, I do think that this estimation is quite low. I would expect this maybe to be in the order of about 500 rand for the work, for just the welding of this plate, etc. So I would definitely increase some of those values quite significantly, most likely the steel grade, because what I want to consider is also in a workshop that they have to move this beam, that they need somebody to come and fit this plate and then weld it, etc. We need to do testing potentially. So I would probably increase that steel grade to possibly over 1,000 rand a kilo, just to incorporate some of the costs that come from the work that needs to be done in the workshop. But regardless of that, the effect would have been the same in that we have reduced the cost of this connection by over half. So this really is an incredibly helpful tool. And of course, as your experience grows, you will better be able to look at the cost versus the actual connection. And I would assume at some point really get close to setting up your IDEA StatiCa costing in such a way that it becomes something that you can actually use to price certain items in a project. So I really hope that you've enjoyed that. Thank you so much for tuning in again. Please feel free to reach out if you have any questions. Other than that, there are 2 more clips coming for this month. So that's the month of July. And I hope that you'll check them out and like and subscribe. Have an awesome day further and see you soon.